implementation. Now, this continued to work on this project, I quickly found out I need a different implementation of sessions. If I want to use this new implementation, I would need to call the create and check session function by providing a new instance of this new implementation. Now, this obviously wouldn't work and will give us a compiling error because the create and check session function takes in a parameter of a different type. Now, what should we do here? Should we type different parameter as a in the stack or stored in the heap? Often, values are stored in the stack when copied by value, and values are stored in the heap when copied by pointer. Because the value the pointer is pointing to needs to be kept alive even after the function is popped off of the function stack. This means that the values on the stack are self-cleaning, while the values on the heap require the involvement of the garbage collector. Additionally, if we were to add a concurrency into the mix, parameters passed by value will live in the corresponding GoRoutine function stacks, whereas parameters passed by address will live in the common heap and accessible by multiple GoRoutines, and this can further worsen the performance. The next mistake Go beginners often make is not using enough interfaces. Interfaces in Go are very powerful, and many features in other languages are consolidated in Go with the usage of interfaces. Let's take a look at this example from one of my personal projects. This is a simplified version of the session management project that I worked on. As you can see, the create and check session function takes in a parameter of type sessions info. Notice that this is a concrete struct type. The code we currently have works perfectly fine if we only have a single implementation of sessions. However, as I continued to work on this project, I quickly found out I need a different implementation of sessions. If I want to use this new implementation, I would need to call the create and check session function by providing a new instance of this new implementation. Now, this obviously wouldn't work and will give us a compiling error because the create and check session function takes in a parameter of a different type. Now, what should we do here? Should we keep the same function but update the parameter type? Or should we add an additional function with this new implementation? These brute force solutions simply aren't going to work because they require us to revisit and refactor our code every time we add a new implementation. This is where interfaces come into play. We can add an interface with a common method and then update the type of the function parameter to this newly created interface. This is especially applicable when you are writing tests. For example, if you have a struct with a member variable of type interface that you want to test. Because the member variable is of type sessions and interface type, we can create a mark session struct type that implements the interface method with marked behaviors. you can use this mark struct in order to instantiate the components that you're actually trying to test. Next, let's talk about loop breaks in switch/select statements. Let's use this example that attempts to break the for loop when the channel receives a break signal. As you can see, we have an infinite for loop even though we have a select statement that attempts to break the for loop when it receives the break signal. That's because a break statement not only breaks for loops but also attempts to break switch and select statements. So in order to have the break statement to break where we intended to, we would need to add a label for the for loop and provide the break statements with the label of the for loop. This type of mistakes can easily be overlooked because it's a runtime error. And especially in a casual side project without a full test coverage. The next mistake that Go beginners often make is blindly using third-party test libraries. There are actually quite a few test libraries that may be very popular, however are not very idiomatic. For example, here we have have two unit test functions testing the session implementation that we had as an example earlier in this video. The first function uses the native testing package and checks the result manually with an if statement, which is recommended by the Go team. The second unit test uses the third-party test library Testify, which uses assert instead of if statement. At first glance, these two functions do exactly the same thing. However, there's actually a minor difference. The first function, where we use the native testing package, actually encourages us to use fatal instead of error, which grants us more fine-grained control, such as terminating the unit test sooner. And these potential performance improvements can easily add up in a larger and more complex project. Similarly, there are third-party test libraries such as mocking libraries that typically uses reflection instead of manually implementing mock struct. This can introduce additional performance drag as well. Next, we have a variable scoping when working with Go routines. Now, pay special attention for the next 10 seconds because I've got a question for you. Here we have a simple set of instructions utilizing Go routines. My question for you is, what do you think the 3 digits are that this concurrent program will end up printing out? Is it 1, 2, 3, or the same numbers but in a non-deterministic order? Now, for loops are not concurrently saved by default, so by when the newly spun up Go routines try to print out the integer I, the main Go routine has most likely already looped to the last element in the slice S. Therefore, this program will most likely print out 333. And if we actually want to have the program print out all 3 numbers exactly once, and at the same time still take advantage of the Go routines that Go provides, there are 2 potential easy solutions. As you can see, both solutions require us to pay closer attention to the scope of the variables that we pass down to the newly spun up Go routine. The next mistake Go beginners often make is related to the non-addressability of certain built-in types in Go. Let's take a look at this simple example of how map values are actually not addressable. The third line here will unfortunately give us a compiling error. To fix this, we can simply assign the map value to a standalone variable first. This applies to slices as well, as slice values are also not addressable. Now, that's a pretty straightforward. However, what's typically more confusing to Go beginners is that concrete values stored in an interface are also not addressable. Here we have a Ninja struct for demo purposes that has two methods, one of which takes in a parameter as a regular Ninja object, and the other one takes in a Ninja object pointer. And we have interfaces and functions that call the parameter as a regular Ninja object, and the other one takes in a Ninja object pointer. And we have interfaces and functions that call those two methods respectively. What's confusing to a lot of beginners is how these interface methods and functions are to be called. Pointer receiver and value receiver methods can be called with pointers and values respectively, as you would expect. And value receiver methods can be called with pointer values because a pointer can be dereferenced. However, pointer receiver methods cannot be called with values because values stored inside of an interface are not addressable. Another mistake beginners often make is creating these conditional clause spaghettis. As you can see in this example, in the check even and negative function, we have quite a few condition checks. For each integer parameters we pass in, we check if this integer is even and or negative, resulting in this huge mess of if-else statements. Additionally, if requirements changes and we want to add additional parameters, the next
"10 years ago, Lenovo's Yoga brand invented the very first convertible laptop, and now, to celebrate, this is the new Lenovo Yoga Pro. Pro is very important. Pro 9i, which is no longer convertible, but also heckin' powerful. Let's check it out, and huge thanks to Lenovo. This right here, in all of the world, is the Lenovo Yoga Pro 9i, except for in North America, whereas the Lenovo Slim Pro 9i, which is different than Lenovo Yoga Slim. Totally different laptops. Anyway, we've got two of them though. This right here is the 14-inch, and let's see what it has for a charger. Here we have a 140-watt charger, which is being delivered over USB Type-C. Love to see it. Man, over 100 watts. Type-C, they're actually doing it. And this right here is a very small brick. This has to be gallium nitride. Also here, we have the 16-inch, not Yoga in North America, Pro 9i. Let's see, is there anything else in here? Presumably, if you get an actual production version. For the 16-inch, we have 170 watts, but it is not delivered over USB Type-C. The color that we have here is Tidal Teal, and I do have to say, it looks pretty darn good. Around the side, we have a full-size SD card reader, excellent start, guys, 2 Thunderbolt 4s, HDMI 2.1. Aha, fact check. You see that there? And also the power button is on the side right here. So normally when you have a small device and a big device, you kind of just repurpose the motherboard for both of them. Now we'll have to take these apart later and figure out what exactly is on the go, but I can tell you for sure it's totally different on this looking at the I/O. So on this side we have our power input, USB Type A, HDMI 2.1, Thunderbolt 4, and a headphone microphone combo jack. Then around on the other side we have our full-size SD card reader and another water bottle. No real soft spots. 16 the same? 16's a tiny bit softer than the 14, but that makes sense. It's a much larger laptop. Also has a larger trackpad. Jeez, they're spoiling us. Look at this. Larger inch version just kind of gets the exact same trackpad. Here though, for the 16-inch, they have a bespoke, actually very large 6 performance cores, 8 efficiency cores, and a max turbo frequency of 5.4 gigahertz. We'll see how she does in a chassis like this. I imagine that the 115 watt maximum turbo power will not be achieved in this machine, which is okay. Here we also have 64 gigabytes of RAM, although it won't tell me what the speed is. A Micron 1 terabyte SSD, Intel Wi-Fi 6E, love to see that. And the star of the show, an NVIDIA GeForce RTX, impressive. On the 16, the specs are exactly the same. The only difference is that GPU is able to draw up to 100 watts of power, and the total system can draw up to 130. Let's have a little look at this keyboard. So there is a 0.3 millimeter dish in every single key, and they seem to be very happy about that. Also, there is 1.5 millimeters of travel, which should be... Keyboard's excellent. Absolutely love it. Good job, guys. So the edge of the laptop...
The statement would look even more ridiculous. The fortunate part is this can be easily fixed with early returns. As you can see, by using early returns, we are able to get rid of all of the nesting by getting rid of the invalid cases out of the way first. This works especially well in Go because we handle errors by checking if errors are equal to nil, instead of any other error handling patterns such as the more prevalently seen try-catch block. One quick tip that I have to avoid some of the mistakes that I've mentioned in today's video is utilizing linters. Linters are code analysis tools used to flag any bugs or errors in your project in order to make any coding style suggestions. Golang CI lint, for example, is Golang cheat sheets
of organizing code. Packages can be one of two types, executable or main, and non-executable or non-main. As far as the main package goes, you need to declare a main function. The main function is what starts the execution of your program, hence a main package is also called an executable package. Every other package would be a non-main package and should be focused on a specific functionality. So, for example, the built-in package font is for printing and scanning user input and output and nothing more. Additionally, package management is the practice of managing these packages for reusability, which is where the following package management tools are built for. GoPath. In early versions of Go, each package's namespace was the path of the folder in relation to your machine's environment variable named GoPath. Your GoPath, which is a file path and should have a few subfolders in it, /bin, /package, and /source. All your Go projects needed to be in your GoPath/source directory. Now, if you wanted to have a different workspace location, you would need to update your GoPath environment value with a different file path on your machine. As limited as GoPath was, at least when you wanted to install an external dependency package, you can use the go get command, which pulls the external package from the internet to GoPath/source alongside your project. A Go program cannot import a dependency if it is not present inside GoPath. GoPath forces us to locate all the projects inside a specific file path, unless we keep changing the GoPath environment variable value, which is obviously tedious. Go modules. As of Go version 1.11, Go modules become the new way of managing the packages and dependencies in your Go projects. There are the two main concepts that Go modules brought solutions to: dependency requirements and dependency versioning. Dependency requirements indicate what the dependency is and the path to get them. The path of a dependency is made out of the host, the user or organization, and the project or repository itself. On the other hand, dependency versioning helps identify the specific version of the dependencies we want, since dependencies used in our projects can be updated, and a new version can potentially have changes that break our programs that rely on the outdated version. Go modules keep track of dependency requirements and the versioning with the help of two specific files, GoMod and GoSum. The GoMod file lists the path to our own project, the version of Go we are using, the path to the dependencies, and the versions. On the other hand, the GoSum file is an auto-generated file that documents even more info about these dependency packages, such as the path to the dependencies of the dependencies we directly import, and the checksums which ensure the integrity of these dependencies. With the GoMod and GoSum files, package management is handled much more effectively compared to how it was done with GoPath, such as having all projects in the GoPath source directory and not having dependency versioning. This is a major step forward for package management in Go. Go Workspaces. As amazing as Go modules are, when it comes to larger and more complex projects, we still lack a convenient way to handle the versioning changes of packages across multiple modules with ease. For example, let's say that your current module imports the experimental sync package, and you want to replace it with a local version that has your own code. To do that, you'll need to specify it in the GoMod file. This is fine at a glance, but becomes troublesome and sometimes practically impossible if you want to do the same for lots of modules in a larger and more complex project. Plus, you'll need to remember to revert the changes afterwards. With Go version 1.18 and the introduction of Go Workspaces, we're now able to work with multiple modules simultaneously without having to edit the Go mod files for each one of these modules. Instead, we head to the root folder that contains the project modules, run the Go Work Init command to initialize a common workspace, which will create a Go Work file. Then run the Go Work Use command followed by the local version of the package you are substituting. The modules under this workspace will now all use this specified version of the package. This can give us a huge boost in productivity and ease of mind. In conclusion, package management in Go has been a wild ride since Go's initial release. However, we can see that the Go team has provided us with more and better tools along the way, while maintaining Go's philosophy to never compromise on simplicity and developer productivity. We have gone from a tedious and overly strict way of package management to a more flexible and supportive variety of workflow with Go modules and Go workspaces. I'm enjoying and embracing its evolution and looking forward to more to come. How about you? How are you liking these tools in Go? Please comment below with what new